Hi again, everyone. It's Professor Sebastian. Welcome back to our statistics class notes. We're in the top third here to page 81, and we're getting into section 6.2 about the normal model, or sometimes called the normal distribution. This is probably one of the most important sections we've covered so far, as this will, if you understand this section well, then what we learn in chapters 7 and 8 should be not easy, but it should be helpful that by understanding this really well, it's going to help you get over any humps you might have in chapters 7 and 8 quicker. Okay, so one of the most widely used probability models for continuous numerical random variables is the normal model, or the normal distribution. So we're going to learn how to find probabilities using the normal model or normal distribution, and then find values for a random variable given a normal probability, sort of kind of working backwards. And that'll make sense hopefully when we get the examples. So before we go there, I want you to understand what notation we're going to use. So when we're talking about an entire probability distribution, we're not talking about a sample from a population, for example. We're talking about a theoretical probability distribution. Then we use the symbol mu, this is the Greek letter little u, it's pronounced mu, to represent the mean of a probability distribution. And we use the symbol sigma, this is the Greek little s, which is pronounced sigma, to represent the standard deviation of a probability distribution. Then the notation, capital N, of mu comma sigma, so parentheses, you read it as normal distribution with a mean of mu and a standard deviation of sigma, and these are constants that'll be in there, and you'll see in the examples what I mean by that. So it's a normal distribution with a mean of mu and a standard deviation of sigma. That's our notation to tell us we're working with a normal distribution. All right, every normal distribution shares three distinguishing features. One, all are symmetric. So first of all, they're symmetric. They all have a single peak at their center, so they're symmetric and unimodal. And then they all follow the bell-shaped curve. So they're very nice and symmetric, unimodal. Two things distinguish one normal distribution from another: the mean, the population mean mu, and the population standard deviation sigma. The population standard deviation sigma.